In this video, we're going to continue looking at measures of center and position. We already looked at these examples. One thing I want to point out is that in some of the other ones, you'll see outliers that skew the data significantly. So if you were to calculate D on your own, you would see that the average would be pulled down significantly by the addition of this value of 30. If you think about this being test scores, everyone here made a 90 or higher except for two people. One person, if this were test scores, one person got a 70, but one person got a 30. When you average that 30 in with everything else, the test scores are going to be significantly lower. And you can also think about if you ever watch the Olympics when they have like figure skating or gymnastics, things like that get scored. They always disregard and don't count the highest score and the lowest score because they're trying to account for potential outliers. So if everyone said somebody deserved like a 9.9 or 9.8, they were near perfect, but then one country came in was like 8.7, you would think that there might be bias in that response, and so you wouldn't count the outliers. Anyway, all right. We're going to skip this. Example 2, this is just graphing the data sets on the number line in order, and then you label each of the four measures of center on the number line so you can see what happens when you do that. I just filled this out for the first one so you can try on your own, but you can see with the mode being 0, the mode is when you count 0 3 times and average it in, it definitely brings down the average or the mean. Honestly, you tend to want to see your mean and your median be very close to each other, if not exactly the same. That's kind of a sign that there are no outliers with your data. If they are significantly different, in this case with such a small range, this is significantly different, it would cause concern. Anyway, you can do that for the others and see what happens. B might be very interesting because that 30 compared to all those hundreds and 90s and 70s. The next thing that we're going to do is we're going to look at what it means to have a weighted average, which means that some of the input counts more than the other input on the average. So let's look at this. Suppose your final grade for a course is determined by a midterm exam and a final exam. The midterm exam is worth 40% of your grade and the final exam is worth 60% of your grade. If your midterm exam is 84 and your final exam grade was 94, calculate your final weighted average. So typically with an average, if we were to just average those two test scores, we would say 84 plus 94 divided by 2. And this means that these values are weighted equally. Each one counts the same amount. But in a weighted average, they have different weight values. Something counts more than something else counts. So when we are finding and calculating a weighted average, we actually take our percentages, change them to decimals, and multiply them by each piece. So if the midterm counts for 40%, that's going to be 0.40 times the midterm exam plus the 60. Let's do that in a different color. The 60% for the final, so the final exam weighs more. Oh, 94. So when we calculated it over here with them being weighted equally, your average would be an 89. When you calculate it with them being weighted differently, we calculate an average of 90. Now, here's the thing. You're like, wait, we divided by 2 on the regular one, but there's no dividing there. Well, dividing by 2 is the same thing as multiplying by 1/2, and 1/2 is the same as 50%. So if you think about that, this over here is 84 divided by 2, which would be 50% of 84, and 94 divided by 2, which is 50% of 94. So those are technically weighted with every piece being equally weighted at 50%. So instead of dividing by a certain value for the weighted total, we just multiply by that percentage, and it gives us the same process. The next measure we're going to look at is the measure of position, is a measure of position. We're going to look at percentile. If you are in the pth percentile of a data set, that is the value such that p% of the numbers fall at or below this value. So when you hear that somebody scored in the 78th percentile, that means that 78% of people scored at that level or less. Okay, so if you know somebody who scored at the 99th percentile, that means that they probably did better than almost everybody else on that assignment, or typically you hear about this in terms of like the SAT, ACT, etc. So you can, when they say percentiles, it's telling you where is your percentage. We have the scale from 0 to 100, and it tells you if I'm at the 78th percentile, it tells me where I lie, what is my position with respect to everybody else who took the test. So I scored at, or everybody else scored at or below the same score that I did. Now that means that there are, 22% of the people scored better than me. Okay, but that's what percentile is. That's how it shows us position. Another measure of position are quartiles. You might have heard of this before. Instead of looking at percentiles, we're talking about quartiles. Quartiles comes from the word that means four, like quarters. There's 4 quarters in a dollar. So it's setting up and cutting up our percentage of 100% into 4 quarters. Each quarter is 25%. So the Q1 represents this first quarter, Q2 is this one, Q3 is this one, and Q4. So we call this the max or maximum, and this one is the minimum value. And then the Q2 is actually also our median. Okay, so these are the markers that break up our data set into 4 equal pieces. The interquartile range is the range of values from Q3 to Q1. We'll look at an example so you can understand, and who knows, maybe we'll draw a box and whisker plot, which requires knowing all your quartiles. First, let's look at these examples. Josie scored in the 73rd percentile on the verbal part of her College Board test. What does that mean? That means that everybody else who took the test, 73% of them scored at that score or lower. Okay. When a national sample of heights of kindergarten children was taken, Kevin was told that he was in the 35th percentile. Explain what that means. That means that at the 35th percentile, that means out of everybody surveyed, out of all these samples, 35% of them had Kevin's height or lower. Okay. So again, we're just interpreting what these percentiles mean. So my sister had a baby a few years ago, and his head was ginormous, and his head was like in the 99th percentile, which means that pretty much every other baby has a smaller head than this baby had. He's very cute, though. I'm not talking smack about his big old baby head. Anyway, union leader is told that when all workers' salaries are considered, the first quartile is 27,750. Explain what that means. That means that a quarter of the employees make less than 27,750. That means that 3/4 of the employees make 27,750 or more. Okay. So we're going to look at an example in this moment where we're going to find the quartiles of a data set. And so these are the steps to do so. So first you want to list the data from smallest to largest. We already discussed how that's always a good first step because in order to find the median, they need to be in order. So the first thing we're going to do is determine the median value, which is our second quartile of the data set. So if there's an odd number of pieces of data, the median is that middle value. If there is an even number of pieces of data, the median will be halfway between the two middle pieces of data, which we've already discussed before. The first quartile is the median of the lower half of the data. That is, Q1 is the median of the data that's less than Q2. So essentially, once you find the median, you've broken up your data set into two smaller sets or two subsets. And so therefore, then you're going to find the median of the lower subset to find Q1. Then you're going to find the median of the upper subset, which will give us Q3. Remember, we start with a minimum and a maximum, but then we have Q1, Q2, Q3, and Q2 is always our median. So let's look at this example. So we have the prices of the 19 top-rated coffee makers as reported in the September 2014 issue of Consumer Reports are as follows. So the first thing we want to do is we want to take these prices and list them in order from least to greatest. I suggest you do this on your own. I'm going to pause and do it so I don't make you watch. I obviously ran out of space, so they continued all along the side. So we have 19 top-rated coffee makers, so there should be 19 values listed in order from least to greatest. I like to cross off the items as I write them in the list so I don't double count and so that I don't miss anything. If there are 19 values, that means that we have 9, 1 in the middle, and then 9. Okay, you can think of that as, what is 19 divided by 2? Well, that's 9.5. So that middle value is going to be the 10th digit in this set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's going to be 150. I can double check and make sure that on the other side I also have nine values. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you could do the crossing off on each side to figure that out. But since this is a long list, I prefer not to do that. I like to do 19 divided by 2, and then we say we find the, we have to round up to find that middle value. Okay, now if it had been an even number, we would have gotten a perfect even number, so the 2 would have been in the middle. Anyway, okay, so two methods where you can find the median. That the median is equal to Q2, so Q2 is equal to the value 150. Now we've separated this into two sets. To find Q1, we need to find the median of the lower half of the data. So we need to find the median of these 9 values that are less than the median. So this was our Q2. We need to find the median of these 9 values. Well, 9 divided by 2 is 4.5, so that means the 5th value will be our median of this lower half, which will end up being our Q1. So 1, 2, 3, 4, 5. Now double check. Do I have 4 on each side? 1, 2, 3, 4. 1, 2, 3, 4. We're good to go. This is our Q1. 100. Then we do the same thing for the upper half and of the data to find the Q3. So we find there are 9 values. 9 divided by 2 is 4.5, so that's going to be our 5th value. So 1, 2, 3, 4, 5, that's 180. We're just going to check that I have 4 on both sides. 1, 2, 3, 4, 1, 2, 3, 4. So 180 is our Q3. The IQR is we take our Q3 and we subtract Q1. So 180 minus 100 equals 80. So our IQR, or interquartile range, is 80. Here's why this is important. We can use this information to create a box plot. A box plot looks like this, or you might have heard a box and whisker plot. That's what I've always called it. And in our box and whisker plot, this line here represents Q1, this line, or sorry, Q2, our median. This one here at the end is our Q3, this one here is our Q1, and this is our min, and this is our max. Now, a box plot should be performed on a consistent number line. So if in our example, and I might have to redraw this. In our example that we just saw, we had our minimum value was 80. So I'm going to draw my line here. My maximum value of the prices of coffee makers was 300, so I'm going to draw a little mark there. Then I'm going to draw my Q1, my Q2 median, and my Q3. So my Q1 was 100. The Q2, or the median, was 150. And Q3 was 180. So then I have created my box for my box plot. Okay, so I'm going to label those. We had 100, 150, 180. Okay, so what this means, this box contains our interquartile range. That tells us that the middle half of our data, so the values that are mostly in the middle, lie within this box. And then the first quartile reaches out to that minimum on the left. Our fourth quartile extends from Q3 all the way to our maximum. So this kind of plot gives us a nice spread of what our data looks like. The middle part of our data lies between 100 and 180. We then can find would like kind of where outliers might be based on this information. Now, there's one way that we can calculate an outlier. To do that is we calculate Q1 minus 1.5 times the IQR. And if you have any values that are less than that, you get rid of them. And then we also look for outliers that are too big. And so for those outliers, we do Q3 plus 1.5 times the IQR. So our IQR was 80. So to check for outliers, we would do in this problem 100 minus 1.5 times 80 and see if any of our values fall outside of that value or are less than that value. So 100 minus 1.5 times 80 gives me negative 20. None of our prices were negative 20. They're not paying you to take a coffee maker. So we're good on that one. For any upper outliers, we take our Q3, which was 180, and then we add to it 1.5 times our IQR, which was 80, and we get 300. Oh, please let me type. So 300 is an outlier. So when that happens, fun news, that means that this value at 300 is an outlier. So we would put a circle there, an open circle to represent that is an outlier. And then our highest value that's not an outlier is $230. So this is how you create a box plot. You identify your minimum, your maximum, your Q1, your Q2, your Q3, and then you calculate to see if any values are outliers. So I'm going to let you go ahead, hop into your homework. Hopefully this example will be enough to get you through that. If you need additional help, be sure to email me. Thank you so much.